Welcome back. Last time we looked at how vibe coding works in general. Today we're taking it a step further and we're looking at how to do it right for coding agents using PydanticAI. We'll break down the rules, tasks, and some critical gotchas you need to avoid. In the last discussion, we touched on the challenges of generating accurate code with newer frameworks like PydanticAI. Most challenges stem from the fact that these frameworks are newer than the LLM's training cutoff dates. Without the right context, AI-generated code can easily produce hallucinated classes, fabricated parameters, and entirely fictional method flows. This happens because large language models are prediction-based systems. They generate responses based on the probability rather than through understanding. When working with structured frameworks such as PydanticAI, this can lead to unexpected and unusable outputs unless the generation process is carefully crafted. To mitigate these risks, special attention must be given to prompt engineering, context setting, and iterative refinement. Providing the model with precise rules and task definitions, clear constraints, and real-world examples can greatly improve the quality of the generated code. Additionally, validating AI-generated outputs rigorously through PydanticAI's result validators, testing, and human review ensures that the final implementation is both functional and aligned with the best practices. It ensures that it fits your requirements. By following the guidelines in this video, it will be possible to transform AI-generated code from unreliable patchwork into powerful productivity tool without the common pitfalls of hallucination or inconsistency. Now let's take a look at vibe coding and how it relates to PydanticAI. We already mentioned that some of the LLM models' cutoff dates prevent them from actually recognizing PydanticAI and creating usable code. So very few of these models are actually familiar with PydanticAI. The second challenge will be that PydanticAI is changing fast. So between different versions, 0.23, 24, 0.40, there are significant differences and backward compatibility is not a big concern at this moment. So the framework is undergoing significant changes. What works in 0.023 may not work in 0.045. You have to be careful and provide the latest resources to the LLM as context files. Otherwise, it will generate code for a previous version of the library, which will not work with what's inside your requirements.txt file. The third rule here is to use the website PydanticAI.dev as well as the PydanticAI GitHub as a context. So provide that as a context. If you're using Cursor, add it as a web document. If you're using GitHub Copilot or Roo Code, download these websites as HTML or PDF files and add them to the context as folders. Finally, create PydanticAI specific MDC rules, and I'll show you how to do that. These rules tell Cursor how to create your agent files, what templates and architecture guidelines to follow, and follow your specific rules that apply to your project or organization. These are some of the key features which will make PydanticAI work with vibe coding tools. Let's move on. What are some of the applications for vibe coding with PydanticAI? What are some of the things you can create? For example, let's start with single PydanticAI agents. PydanticAI is what I call atomic agentic framework. It's different than LangGraph from the perspective that you create single purpose agents with a tight system prompt that usually are built with one purpose and one task in mind. You can combine multiple agents and that gives the framework strength, but other frameworks such as LangGraph provide orchestration capabilities which PydanticAI does not. So building a single PydanticAI agent, purpose-built PydanticAI agent, is one of the areas of application, and through rules files, through context, you can use vibe coding to create one purpose-built agent. You can also create multi-agent workflows. By extending the rules and by providing extra context, you can tell vibe coding tools such as Cursor or GitHub Copilot how to create multiple agents and how they will be orchestrated. So you can use LangGraph for orchestrating PydanticAI agents, or you can use just straight Python code with if-then blocks to orchestrate and to pass messages between these agents. But you need to instruct Cursor, you need to instruct Windsurf how to create these agents, what rules to follow, and what is the larger task that you're trying to accomplish. Next is full stack agents with APIs and UIs, taking it a level up. Singular purpose-built agents are now working. It is time to build perhaps a fast API endpoint on top of your agent, or even a UI. How would you like to build the UI? It's important to specify whether you want something like Streamlit or a Gradio app, which are simpler UIs for singular agents, or you would like something more capable such as a React, Next.js, Angular, or Vue.js app that is now using the fast API endpoints that are connected to your agents. Now we're getting into 2, 3, 4 layer applications, and that requires more rigor, it requires more planning and more detailed prescriptive prompts that you need to pass to the vibe coding tool. At point 3 is also important to note that the more complex the prompts get, the lower the likelihood that the tool will get it right the first time. I have examples that I've included for building single purpose agents, and a lot of the tools get it right the first time. 90-95% of the time, with strong rules files and task files and a great prompt, you are likely to get a working PydanticAI agent the first time. However, as you start adding API layers, as you start adding perhaps tools or databases or RAG systems or UIs, that probability goes down. So be ready for debugging, be ready for repeating the cycle and providing more feedback to the tool so that they can actually fix their mistakes. Number 4 is agent integrations. How can you integrate a PydanticAI agent with a tool such as N8N or Flowise or Diffie? There are great opportunities for AI startups right now building all sorts of agentic flows for verticals such as medical, financial services, insurance, and education. However, in a lot of these cases, integrating with tools such as N8N or Flowise is an essential part of the job. By using vibe coding, you can create agents that are ready to be integrated with any one of these tools. And in my experience, the best way to integrate PydanticAI agents with any external tools is through an API layer. So build your PydanticAI agent, build a fast API layer on top of that, and integrate your N8N flows through an API call instead of as a custom code block or as an agent block. Number 5 is PydanticAI and LangGraph apps. I did mention this briefly. Combining LangGraph with PydanticAI agent provides a lot more possibilities. You extend the range of applicable business logic and you expand the possibilities by combining the strengths of these two frameworks. By creating great prompts and by providing rule files both for PydanticAI agents but also for LangGraph agents, your tools such as Cursor or RuCode then will generate the right assets. Let's talk about the thinking or the planning process when you're designing PydanticAI agents. I like to start with the atomic agent itself. What are the tasks that I'm trying to accomplish and how many agents do I need? A lot of times a single agent is enough, maybe 2, maybe 10. It doesn't matter, but usually it's a good idea to plan agents with one cohesive system prompt and one task and perhaps set of tools. Think about it, for example, event planning system. In an event planning system, you may need multiple agents. For example, you may need an agent that checks the weather. You may need an agent that checks the travel costs. You may need an agent that checks the catering options. You may need an ordering agent. You may need a photographer or an event management agent. So there are many different tasks that will be part of a great event management system. And in that case, all of these agents will start their lives as a single purpose agents, and it's a good idea to plan them and then understand the interaction between these agents. How will they exchange data and how will the orchestration work? But orchestration will be at a later stage. At this point, it's important to design the single purpose agents and think about them in a simpler building blocks. Number 2 is write great system prompts for these agents. Once we understand the purpose of an agent, then we go and write a great system prompt. I can't overstate how important it it is to write a great system prompt for these agents. It will be literally the difference between a well-performing agent versus a poor-performing agent. Use tools such as Claude, use Anthropic's models, use OpenAI, ChatGPT to write a great system prompt, but test the system prompts and ensure that you have a descriptive, prescriptive, restrictive system prompt that works for that particular agent. Once the system prompt and the agent purpose is in place, then think about the memory, the tools, and the validation. How will the agents exchange information? Memory usually is one way. In PydanticAI, agent memory is just a simple list of messages. You can filter messages and you can pass these messages between agents so that they retain a shared context. It's so important. In the example that I provided with the event planning, it's perhaps important to have one shared list of messages that are exchanged between agents, so each agent has access to the previous set of agents' messages and can use that as a context. That's super important. Tools is another aspect. In that example, I provided maybe a tool to check the weather, maybe a tool to order catering supplies. So those are different tools that you need to be planning. And number 4, also very important, is the design agent orchestration properly from the beginning. For PydanticAI, you have multiple options. You can use plain Python as an orchestration. That's one way. You can use another AI framework such as LangGraph as an orchestrator. And thirdly, you can use a integration system like N8N, Diffie, or Flowise as the orchestration for this. In that way, you can design a whole pipeline of nodes in N8N, and each node can represent a single agent whereby they exchange information in the format of a JSON message. That's how N8N works, and that's how Diffie and Flowise work. Their nodes exchange information through JSON text. This is just a general way of how to think about the planning, and this becomes very important in vibe coding because this is how you would describe the tool create your assets. You would start with describing your agents, perhaps their system prompts, how they should look, and then explain the memory, the tool, the validation result validators, perhaps the result classes, the PydanticAI result classes, how you'd like them created, and then provide an idea of the orchestration tool that you'd like used. One of the ways to start with rules is to use existing libraries. One of those libraries on GitHub is patrickjs/awesome-cursor rules. Take a look at this open source library and see if there's anything that fits your project needs. On the screen here, you see some of the Android and Angular related files. These are for web development, mobile development, but this library includes hundreds of rule files that you can take, use as a basis, customize, and then come up with your own unique set of MDC files. Now, just as a reminder, an MDC file is a rule or a task file that you include in your cursor workspace and add to cursor as a guidance file that it will be used during the code generation process. These files are guardrails. These are the rules that the vibe coding tool will use while generating your assets. The more rigor, the more structure you put in these files, the better the end results will be. We talked about prompts, but it's important to visit this one more time. And great prompts have 3 features. They're descriptive, so you describe everything that you'd like to accomplish, like I presented in the slide before. Here's my atomic agents, here is the purpose of each agent, here's what I'm trying to accomplish. I'd like to use memory, I'd like to use tools, here are the tools that I'd like to use. So the more descriptive, the more details you provide to your vibe coding tool, the better the outcome will be. Secondly is prescriptive. Break down large tasks into smaller chunks and give the tool a step-by-step instruction. That's what it means to be prescriptive. Don't just ask for one large task. The tools will get confused. It will be hit or miss, and you will likely end up spending more time debugging or fixing the code rather than breaking down this large task into smaller prescriptive set of atomic tasks. Thirdly, be restrictive. Tell the tool what not to use, what libraries to avoid, and what not to do. Tell it, for instance, instead of always going and creating a new method, to first inspect and see in the workspace if there's already a method that does something similar. And if that's the case, then to refactor that method and reuse that method instead of creating logic that is very similar across multiple files. That's one of the pitfalls of vibe coding or code generation, is that tools sometimes ignore existing assets and just keep creating new files and new lines of code. Remember that the more lines of code you have, that means the more code you have to maintain later on. In that line of thinking, restrictive means the more restrictions you put, the more rules you provide, the better the outcomes are. Another way of thinking about prompts is think of the agent that will create your code as your new coworker. When you hire a new coworker, let's say a junior developer in the team, you put them through a boot camp, you put them through training. Maybe it's a week-long training, maybe it's a month-long onboarding to your company. You teach them the rules, the libraries, the standards, the architectural patterns to follow, perhaps the Scrum meetings. This agent will likely end up going through a similar quote-unquote training process so that they are familiar with your standards and your expectations in order to create usable code. If your junior employee, after a month of this training, is still unable to create good code, then maybe the standards are outdated or they need more training. And the same thing applies to the agent. After all these rules and everything, you're still not getting the results. That means something is missing, and you need to provide more guardrails, more rules, or change the model. Here's a sample prompt that I included just so you have an idea on the level of rigor and prescriptiveness and restrictiveness of how to write a single prompt for an atomic PydanticAI agent. In this case, we're dealing with a medical advisor agent for holistic health. I included the response type should be a structured Pydantic model called health question response, which should include all relevant fields. Now, I'm not specifying which field should be included in the health question response. That's the job of the LLM to come up with that class and that structured response. But you could also, if you have strict requirements of how the response should look like from this agent, then include it. And you could say something like it should have an answer, it should have a rank for the answer, perhaps the source of the information as well. So be as descriptive as possible, and later on you will see I have a set of steps so that it's very prescriptive. The agent knows how to create my agent code. So the Vibe Code tool knows how to create my Pydantic agent code. I specify down to the level of which models I'd like to use, how to create my decorators with @agent, @tool, @agent.toolplane, or @agent_system_prompt. Let's take a look at a quick conversation I had with our school members on creating PydanticAI assets using vibe coding. So the first thing I want to go and show you guys is this PydanticAI website. It's good to read this website. The reason is twofold. It changes quite often, and you'd be surprised what you learned last week, how it's not backward compatible. It is broken. Your scripts no longer work. So it's good to come here and be familiar with this website in general. The second thing is, thanks to a member, he scraped the entire website and sent me a zip file with JSON files. This is important because for certain tools, you are not able to give a web root. So to Cursor, you can add a web root. So I'll show you how to do that. In Cursor, the way to add context is you come here and you say add context. And from the add context, you can just go to docs. And from the docs, you can just add any website you like. So as you can see, if I've added PydanticAI and the PydanticAI GitHub website, two of those have already been added. Refer to PydanticAI, refer to the PydanticAI GitHub, and now I'm going to ask my question or whatever that goes into agent mode. Without proper context and without proper rule files, you're going to end up spending a lot of time. It's just going to spit out a lot of garbage, and you'll end up spending more time fixing it than actually doing useful coding. You need to understand and learn each tool how to add this context. This is the Visual Studio Code interface, and as you can come here and want to add any context, there is no way for you to add a URL. But there is something called folder. And here as you can see, in any of my projects that I'm going to start doing vibe coding, I add a folder called context. So I add this to the context, and as soon as I add it, it shows up here. Now I want to show you what's inside my context folder, because it's similar to Cursor and the other tools. First of all, it's the entire pydantic.dev website in JSON format. JSON files that this guy sent me. I'll be sharing this with the community later on. If you want to have context and you want solid, real data, these are the JSON files. The second set of context files are the rules files. And these rules files are also super important. And I'll show you just 5 rules files that I've included, but there's a GitHub repo, which is a rules generator. And you can just clone the repo and you can generate any set of tools for the platform or stack that you're using. For example, I created this pydanticai.mdc file, and it's basically a long file explaining the process, the standards, how I want the files created, everything so that the agent looking at this file knows exactly how I want my PydanticAI agents created. This is Cursor rules. So basically, create these rule files as complicated as you want or as simple as you need them to be. In my case, I have one for Python, one for PyTest, one for Pydantic. This is PydanticAI, and one for Poetry. All of these are telling the tool how I want things created, and you add it like this to the context. I use the tool for doing this. This is just too much to write, and I'll show you the tool. So the first thing I want to go and show you guys is this PydanticAI website. It's good to read this website. The reason is twofold. It changes quite often, and you'd be surprised what you learned last week, how it's not backward compatible. It is broken. Your scripts no longer work. So it's good to come here and be familiar with this website in general. The second thing is, thanks to a member, he scraped the entire website and sent me a zip file with JSON files. This is important because for certain tools, you are not able to give a web root. And this is another tool that I'd like to share with you, and it's the Markdown rules generator for Cursor and other tools. This is an open source GitHub repo and a tool that you can clone from Sanjeet5/awesome cursor rules MDC. And the link to this will be in the video description, so you can just go ahead and clone this repo. But in this quick demo, I'd like to show you how to get this tool and how to make it working for your rule files and how to create PydanticAI assets for your workspace. So just go ahead and navigate to the GitHub repo. And if you search for PydanticAI, you will see that there's no PydanticAI rules currently in the GitHub repo, but there is a Pydantic MDC file, and you can read here about the base model, how to define schemas or annotations, and this is all good stuff for basic Pydantic models. But you can clone this repo, and I'll show you how to make this work and create a PydanticAI rule set. Just go ahead to the main page of the repo, hit the green code button, and copy that HTTPS link. Once that's copied, open a terminal or in Visual Studio Code, however you'd like to check out code. So just type git clone and paste this. So git clone and the URL. I've already done that, but this will basically bring down all the files from the remote GitHub repo to your local machine. Once the code is there, navigate to the folder and open a Visual Studio Code instance from that folder. Okay, once inside Visual Studio Code, you will realize that there are multiple files. Rules.json is one of the more important files. We'll look into that later. Rules.json, for example, and look for different frameworks. Tailwind CSS is one of the libraries included, as well as Jetpack Compose. There are hundreds of stacks and libraries included here in these rules generators. The rule is a very simple construct. This is a simple JSON file. It's composed of a name and tags. This tool uses LLM. You will need to create your .env file based on the .env example. In the .env file, please include the keys for your LLM. And in my case, it's an OpenAI. Just include your OpenAI key so that the tool can use that to generate these files. We're going to go and create a rule entry for PydanticAI here. Just copy one of these tools. So for example, you can copy Pydantic and paste it and name it PydanticAI as the name. And then for the tags, I included AI agent, LLM, Python, and framework. So feel free to expand this list as needed, but these are the tags that the LLM will use with its system prompts to generate these MDC files. Once this is ready, save this file. So the rules.json will be saved, and then we'll run the generation script. Open a terminal and run the script with uv space run space src generate mdc files.py. In order to run this, you need that .env file and you need to update the rules.json. These are the only two changes that you need to make, and then run the tool. And once the generator runs, you should see a success message. And in my case, it says successfully copied rules.json. That's the source of truth. And then it created rules.json readme, and then it created all the MDC generation files. Let's go ahead and inspect what files we have created. In the list of files, as you can see, there's a gazillion files here for Java, Kubernetes, Keras, Heroku files, MongoDB, Phoenix. If you have a stack and you have a tool that you need files for, but it doesn't exist here, this is the way to add your rules file and regenerate. And you can check in these files to your own repo later on. But let's go ahead and find the PydanticAI MDC file. Yes, it's right here. So it's already been generated. Let's take a look at what's inside this file. And one thing you'll notice is that the generic version of this file may be bland for the same reasons that the vibe coding tools are not able to generate extensively PydanticAI code, is because the models are not trained with PydanticAI. And so what you'll see here will be a generic starter rule file. You will have to modify this. So just take a look at how this was generated. You'll see that we have a folder structure. That's very important. And then section 1.4 is particularly important. It's the component architecture. And currently you see 4 areas there: agents, models, tools, and dependencies. These are not enough to create solid PydanticAI agents with vibe coding. So what we're going to do is I'm going to paste my customized set of rules to section 1.4. So instead of 4 rules, we'll end up with something like 20 different rules, and I will tell the vibe coding tool, Cursor or Visual Studio Copilot, how to create my agent files. Let's go ahead and customize this file. I'll go down to section 1.4, and once I'm at the end of that dependencies section where it says inject them via the run context, which is okay, I will paste my set of custom rules, and I'll walk you guys quickly through those rules. So here I will paste my set of rules. Let's start with the top one. The agent must use the OS and .env packages to read OpenAI API keys. So one of the things I do in my tutorials is that I always use the OpenAI, specifically the GPT for all mini models, because they're cheap and fast and they fit the purpose for small agents. So that's what I'm instructing here, is that use the OpenAI key from my environment and use the .env package. Then if you look at line 85, I'm instructing it to first create the model instance, passing the model name and the API key, and I provide an example. This is again very important. If you don't do this, the vibe coding tools do not know how to create a PydanticAI agent. They just use references from other frameworks that become very, very confusing. They use classes that don't exist. They hallucinate new methods such as .invoke that doesn't exist in PydanticAI. So be very clear and prescriptive of what you want. And in my case, I even go as far as to provide an example from one of my agent files, and I say, this is exactly how I want it. I want GPT-4o mini with the provider. On line 88, create an instance of the agent using the PydanticAI agent class, passing the model. Then line 91, if the tools don't need access to the runtime context, use the @agent.tool plain decorator. Otherwise, use @agent.tool. It's very important to specify if they need the context or not, passing the runtime context as the first parameter. It's very important that the runtime context is the first parameter at the @agent.tool decorator. Otherwise, the method will fail and you will have to spend time debugging. On line 93, then create a system prompt, and now I'm instructing how to create a system prompt with the @agent.systemPrompt decorator. Ensure a descriptive step-by-step instruction and how to run the agent and use the tools, as well as the structure of the result type. It's important that the structure of the result type is part of the system prompt, and the system prompt instructs the agent to return the result type. Then line 95 is connect the tools and the system prompt to the agent. If you don't specify that, sometimes the connection is not established. Now, continuing line 97, if the test methods invoke agent.run, and then I'm specifying if the test methods invoke agent.run, they should be asynchronous and must run.run. To finish, the response from the agent will always be encapsulated in .data, so that make sure that you get that before performing any assertions. If you don't tell the model to use .data, it doesn't know how to extract the data. I'm specifically asking to create a main loop inside the agent. Now, this rule is very specific to my workflow. That's how I create my agents, because I like to keep them simple. If you're creating agent to be used by others, such as a fast API endpoint, you do not need a test or run method inside the agent. So you should instruct your agent to act as just as an atomic agent, and then add a fast API endpoint on top of that, so that it imports the agent logic and calls it from the API endpoint method. But in my case, it makes it simple. So just be aware that what I'm showing here is not a universally applicable template, a golden source that you can just apply to anything. This is just specifically for creation of small single-purpose agents that can be run within one Python file. Now, in line 101, use the latest version of PydanticAI. Use the following imports for OpenAI. If you don't specify that, again, the tool has no idea which classes to use. And I mentioned that PydanticAI changes its OpenAI definitions quite often. And so you need to provide this OpenAI provider, because this is new as of version 0.4 and X. And moving forward, then on line 105, what you're going to see is only use classes from the provided references, again being restrictive. Don't go and invent new classes, new methods. I'm also providing the two URLs, although I often also provide them as context, web context to cursor URL, or additional context to other tools, but it's good to include these URLs here: ai.pydantic.dev or https github.com/pydantic/pydanticai as reference. So these are about 20 different rules, and they work for creating single purpose agents. All right, now let's summarize. Vibe coding requires discipline and planning. It's not a coding by feeling. It's not a wishy-washy thing. It's not that I feel good and I'm going to start coding today. Of course, there is a level of feeling, and it's great that it opens up the field to be more inclusive and to bring in a lot of talent from non-technical fields. But definitely it does require a level of planning, understanding, and rigor and discipline. So this is where the hype must be separated from the real. There's a lot of YouTube talking heads that will make you think or believe that vibe coding is this great new thing, and that I've created an app in 1 hour and it's working. Reality is that vibe coding has a great potential and can shorten development times by order of magnitude. But you need to understand that solid software engineering is not just coding. Coding is perhaps 10 to 20% of a great effort. The rest is analysis, architecture, design, testing, debugging, troubleshooting, putting systems in production. Coding is a relatively small part of this entire workflow. So while vibe coding can save significantly during the coding, do not make the mistake of assuming that it will change the entire workflow completely end to end. Not yet. It's getting there. The tools are getting better. But as of today, you still need a little bit of planning. You still need a little bit of architecture, testing, and then putting things in production is not as simple as it may seem. So planning, rigorous discipline, understanding how tools work, repetition, iterative development, experimentation, learning, taking notes, improving the prompt, sharing your results with the community. For example, I mentioned about the AI software developers is a great school community. We have members that are experimenting and sharing their experiences, their lessons learned, their battle scars, their templates, their rules files. A lot of the rules files that I shared today for PydanticAI, for others, are already part of our shared library, and all members have access to these. GitHub is full of such files. The important thing is to look for them, to be aware that they exist. Don't start from scratch. Even if you did start from a blank slate, use an AI tool such as Claude to generate a base file and then customize it as I showed you. Writing great prompts requires a little bit of discipline and a little bit of experience. You'll get better over time. Even if you're coming from a non-technical background, writing good prompts will take a little bit of time. This is where it's important to socialize with technical co-founders, to talk to your technical team, perhaps to your tech lead, or even to technical people online on Reddit or forums, or joining a community such as AI software developers can greatly help you become a little more technical. Even if you're a non-technical co-founder, having an association with a technical community can allow you to actually get into that groove of how does technical stuff work. Even if you're not an engineer, you don't have to become a full coder for this, but understanding at least how to think about constructing a system will be very helpful. Most of the time, what I see with founders is that the most successful founders understand the frame of thinking. It's not the little nitty-gritty details, but the big picture, step-by-step thinking matters a lot. So if you get the bigger blocks in place, you can fill in the gaps later on. You can read, or you can use AI to either debug or troubleshoot some of the problems. But if you're missing the big picture, it's very difficult to fill in some of those gaps later on. We've come to the end, and so I'd like to thank you for sticking around. I hope that now you're convinced that vibe coding with PydanticAI can significantly change your agent development workflow for the better. Learn these techniques and you'll build sophisticated AI agents, and over time you'll get faster with better validation and more complex workflows. In addition to that, you'll also learn how to take PydanticAI atomic agents and make them part of larger systems, because let's face it, a single purpose agent, it's not very useful. While it's easy to build, while PydanticAI gives you the building blocks, really truly useful systems, unique systems that deliver value to end customers, are usually composed of multiple agents working together. Whether that's part of an N8N workflow, LangGraph orchestrated agent network, you'll have to build sophistication with multiple agents. But having a solid vibe coding foundation with the assets and the context files will give you the jumpstart that you need to start that route. A structured approach to PydanticAI prompting will give you a significant edge also. That's another thing. And that's important when implementing agent-based systems that solve complex problems. If you found this deep dive helpful, hit the like button, subscribe, and let me know in the comments, how will you implement PydanticAI agents in your projects? Are you building single purpose agents? Are you combining multiple agents? What models are the most useful for you, and what customer challenges are you solving? Also, let me know if you're a technical or a non-technical co-founder, because it's really interesting to see how many non-technical people are entering the field thanks to tools such as Cursor and Copilot. These are great enablers, they're great transformational tools, and I'm happy to see more and more inclusivity in the community by using vibe coding as an enabler. Thank you for watching. See you in the next one.